Hi students, in the last video I have discussed some important topics for ICSE. Now I am continuing with that. In this some more important topics are being discussed. So these are already discussed in detail under different headings in my videos. You can watch them under various topics. Now in this video I am starting with some reactions. Characteristic reactions of acids. Characteristic reactions are reactions of the dilute acid, which is a strong form of the acid. Number one is acids react with alkalis to give salt and water only, which we call as neutralization reaction. Example, you take the alkali NaOH, it will react with the acid HCl, hydrochloric acid. You will have the salt NaCl plus H2O. And if you take sodium hydroxide and react with nitric acid HNO3, you will have the salt NaNO3, sodium nitrate plus H2O. Okay, now if you take sodium hydroxide with the sulfuric acid, I'm taking the three strong acids. Okay, that is what will be asked in question. Now here you have, because it is a dibasic acid, it will need two sodium atoms here. Na2SO4 will be formed and two molecules of water will be produced. So 2 NaOH is required. Okay, so you may write it with any weak alkali also, NH4OH plus HCl. What you will get? NH4Cl plus H2O. Same way, NH4NOH plus HNO3. Take nitric acid. What you will get? NH4NO3 and water H2O. Now NH4OH plus sulfuric acid you take. As I said, this is dibasic acid. Two molecules of the alkali will be required. So NH4 hold twice SO4. Sulfate is divalent, and therefore two molecules of water will also be produced. So this is the first characteristic reactions of acid. Okay, so these are important. Please study. The second characteristic reaction of acid is acids react with active metals to give salt and hydrogen. Active metals are, see, magnesium, zinc and iron. So these three are considered as active metals for class 10. Okay, now aluminum and all will come, but we are not including them for our study. So these can react with acids. Reaction with hydrochloric acid, it will give MgCl2 plus hydrogen. Okay, zinc reacts with hydrochloric acid, will give MgCl2 plus hydrogen. Iron reacts with hydrochloric acid. Sorry, this is zinc chloride, no? ZnCl2 and H2. So here it will be FeCl2 plus H2. Okay, so balancing the reaction, 2 chlorine are here, Cl2, they are all divalent metals, 2 HCl, 2 HCl and 2 HCl. Okay, the rest is done. Now let us take the next acid, Mg plus H2SO4, sulfuric acid. Okay, MgSO4 plus H2. Divalent metal, dibasic acid. Nothing to be done. If you write correct formula, it will be self-balanced. Zinc plus H2SO4, same thing. Okay, ZnSO4 plus H2, self-balanced. Fe plus H2SO4 will give FeSO4 plus H2. Alright. Now if you take nitric acid, HNO3, nitric acid does not give hydrogen, that we have studied. So it will produce hydrogen only with magnesium at a very dilute stage. Okay, 1% cold nitric acid, otherwise it does not. Then we have the third. By the way, there is one thing called observation possible here, because hydrogen gas is evolved in this. What will be the observation? Colorless gas, colorless and odorless gas. Gas evolved and burns with a pop sound. Pop sound, not on its own, when a glowing splint is introduced. Okay, observation can also be asked, equation can be asked, name the gas evolved, that can be asked, or write the name of the products, that can also be asked. Acids react with metal carbonates and bicarbonates to give salt, water and carbon dioxide gas. Okay, since carbon dioxide gas is evolved, what will be the observation? Colorless, odorless gas evolved turns lime water milky. Okay, now if you pass the gas through potassium dichromate solution, there will be no color change. Okay, now let us write the reaction. The carbonate, metal carbonate, sodium carbonate, Na2CO3 reacting with hydrochloric acid, NaCl plus H2O plus CO2 as per the reaction. Salt, water and carbon dioxide. Na2, 2 sodium is there, 2 HCl will be required, 2 NaCl will come. It is balanced. Now Na2CO3 plus HNO3. As I said, there will be 2 HNO3 because there are 2 sodiums. They are monovalent. This is a monobasic acid. Since there are 2, there will be 2. Okay, right. So we will have NaNO3, 2 NaNO3 plus H2O plus CO2. Okay, then Na2CO3 again, sodium carbonate. Let's take H2SO4. So dibasic acid, 2 sodium, it will be perfectly balancing. So you have Na2SO4 sodium sulfate and water and CO2. Okay, now let us take a bicarbonate, sodium bicarbonate, NaHCO3 plus HCl. Here what you get? NaCl plus H2O plus CO2. Nothing to do, self-balanced. NaHCO3 with HNO3. The salt will be the nitrate, sodium nitrate, NaNO3 plus water and CO2. Nothing to be done, self-balanced. NaHCO3 plus sulfuric acid, dibasic acid. We need 2 sodium, 2 has to be put here. So you have Na2SO4 plus, since there are 2 CO3, there will be 2 CO2 and 2 hydrogen makes 4. So there will be 2 H2O. Okay, so this is about the third reaction. Now fourth characteristic reaction of acids. These characteristic reactions are important. You must write and practice these reactions. Acids react with metal sulfides and bisulfides to give salt, water and sulfur dioxide gas. The very important thing, very interesting thing to note here is, if you have learned these carbonate, the sulfite is very easy. Exactly the same. You will only replace carbon with sulfur. So I am going to do that only. So here the observation first let us write. The sulfur dioxide gas will be colorless gas with pungent odor. It has pungent odor, turning potassium dichromate solution or paper, a filter paper soaked in potassium dichromate solution, to green. It will turn green. Okay, let's write. There we took Na2CO3. Here you will take Na2SO3. Okay, Na2SO3. Na2SO3 instead of CO3, SO3. HCl, HNO3 and H2SO4. 3 acids are also taken. Now let's see salt, water and sulfur dioxide. What will be the salt in this case? As I said, 2 sodium, 2 HCl will be required. 2 sodium, 2 HNO3. This is dibasic, it's balanced. Okay, what will be the product? Here it will be NaCl. 2 NaCl, 2 sodiums are there, plus H2O plus SO2. And here you have 2 NaNO3 plus H2O plus SO2. And here you will have Na2SO4 plus H2O plus SO2. Okay. Now NaHSO3 can be there, next one, NaHSO3. So you can just check here. NaHCO3, change the carbon to sulfur and write equation. And the bisulfite questions are rarely asked, so I would not write this. If you want, you can write and practice. Let's go to the next one. The fifth one is acids react with metal sulfides to give salt and hydrogen sulfide. Hydrogen sulfide is evolved. The observation will be colorless gas with the smell of rotten eggs. That is the smell of hydrogen sulfide, rotten eggs, turning what? Turning lead acetate paper silvery black. This is the test for it is evolved. Okay, now let us write the reaction. Na2S, sodium sulfide. Na2S, only sodium sulfide will be asked. No need to write so many sulfides. Sorry, HCl, hydrochloric acid. Here we take HNO3, nitric acid. Here we take H2SO4, sulfuric acid. Okay, what will be the reaction? The salt here, Na2S. So what you will require is 2HCl, 2HNO3. Same. Okay, so this will be 2NaCl plus H2S. Here you will have 2NaNO3 plus H2S. Here you have Na2SO4 plus H2S. Okay, so I think that is clear. Going to the next one. Now we have reactions of concentrated acid. Hydrochloric acid reacting with manganese dioxide, MnO2 plus hydrochloric acid. So this has to be heated. So you will have MnCl2 plus water and chlorine. Okay, so 4HCl will be there, 2 water, so it is balanced. Now the chlorine gas is evolved, so the observation will be greenish yellow gas evolved. Okay, now dilute hydrochloric you take and react with manganese dioxide, there will be no reaction. So this reaction can be also used for differentiating between dilute and concentrated hydrochloric acids. Then nitric acid, the reaction with copper. Now please mark this importantly. This question will be there in the question paper in any form, one form or the other. It will be there. It is observation or name of the product, name the gas evolved, or writing equations, or differentiate between dilute and concentrated nitric acid. This has to be in the question paper. Please note that. So you have copper plus nitric acid dilute. Okay. Now this is a little difficult to balance also and tricky also. The product will be copper nitrate and water and nitric oxide, NO. Okay, now if you take copper and concentrated nitric acid, this is concentrated, so here it will be copper nitrate plus water and nitrogen dioxide. Now copper nitrate is blue color, so the solution will turn to blue color. Okay, and water of course is in the solution. Nitric oxide, NO, is colorless. So colorless gas evolved. Here it is reddish brown gas evolved. Reddish brown gas evolved. Okay. Now here the colorless gas evolved. When it comes to the mouth of the test tube, it combines with oxygen of the air, changes to NO2. So when it comes out of the test tube, it turns red or brown. And here reddish brown gas comes from the bottom of the test tube. So what is the observation here with dilute nitric acid? Colorless gas evolved, turns brown at the mouth of the test tube. And for concentrated, reddish brown gas evolved. Okay. Now this is the difference. Now the equation is not balanced. You have to balance. The concentrated nitric acid, very easy to balance, is 2H2O and 2NO2, 4HNO3. Okay. Now for this dilute one, again oxygen is 1, so 2 here. So 2 and 3 and 3. Please remember, put 3 on copper to make things easier. 8 and 4. Okay. So many children don't remember to put 3 on copper. They don't touch this. They try to do other kind of balancing. It does not work. Always for dilute nitric acid with copper, 3 copper and 3 copper. This you put first. The remaining will work out. Okay. Right. Now different kinds of question can be asked. If a question can be asked about how do you differentiate between dilute nitric acid and concentrated nitric acid, that's a question. So what you can do is heat both with a piece of copper. In the case of dilute, you have colorless gas turning brown at the mouth of the test tube. For concentrated nitric acid, reddish brown gas is evolved from the bottom of the test tube. Okay, or equation can be asked. Sometimes name the gas in each of this case, dilute and concentrated. So this will be there in your question paper, don't forget that. Then sulfuric acid reacting with copper and sulfur. Copper, we are talking about reactions of concentrated acid, so it is con H2SO4, okay, not dilute. Concentrated will always give sulfur dioxide, CuSO4 plus water and sulfur dioxide. So this will be the reaction, 2H2SO4, 2H2 and SO2. Sulfur dioxide, so the observation will be colorless gas with pungent odor turning potassium dichromate paper green. Sulfur with sulfuric acid concentrated, what you will get is it will change to sulfur dioxide and water. Okay, sulfur is oxidized to sulfur dioxide and sulfuric acid also gives sulfur dioxide. So 2H2SO4, 2H2O, 3SO2. Okay, so that is how it is balanced. Sulfur dioxide again coming. So remember this reaction, any one of this can be asked. And then reaction of concentrated sulfuric acid with sodium chloride, NaCl plus con H2SO4. There are two reactions possible. One is below 200 degrees Celsius. We know this reaction, NaHSO4 plus HCl. Now NaCl plus H2SO4, this is concentrated, remember that. If the reaction temperature goes above 200 degrees Celsius, it will be Na2SO4 and HCl, 2HCl, 2NaCl. Okay. Then concentrated sulfuric acid reacting with hydrated salts. CuSO4.5H2O is a hydrated salt. It is a blue crystal. Con H2SO4 is added to it. It will change to white copper sulfate powder and the water 5H2O will be absorbed by the acid. So this is white powder, blue crystals. Okay, these are some reactions of concentrated sulfuric acid, important reactions. Then properties of gases, hydrogen chloride and ammonia are important gases for you. So here the density, hydrogen chloride is heavier than air, ammonia is lighter than air, remember this. Solubility, both are highly soluble in water. And then we have physiological nature, this is non-poisonous but this is poisonous. And acidic or alkaline solution, HCl is acidic, NH3 is alkaline. Method of collection, upward displacement of air, downward displacement of air. Both are not collected over water as they are highly soluble. Then drying agent, here it is corn sulfuric acid, here it is quicklime. Okay, remember these things. Then we have preparation of ammonia from sal ammoniac. This is and nitrites. Preparation of ammonia, other important reactions. Sal ammoniac is NH4Cl plus we have sal ammoniac reacts with slake lime, calcium hydroxide. So you have NH3 plus CaCl2 plus H2O, 2NH4Cl, 2NH3, yeah, CaCl2 and H2O, 2NH3, yeah, 2H2O. Okay, so it is balanced. Then the nitrides, magnesium nitride, Mg3N2, and ALN, aluminum nitride, they can react with water. So these are methods of preparation of ammonia, remember this. So here you have MgOH whole twice, magnesium hydroxide plus NH3, 2NH3, 3MgOH whole twice, 6H2O. Okay, and ALN, here you have ALOH whole thrice, aluminum hydroxide plus NH3, so 3H2O. This also is balanced. So these reactions for preparation of ammonia. Then in the laboratory method, there are some reasons Why is the flask kept sloped? Flask is sloped to prevention of trickling of cold water into the hot base of the flask and to prevent sublimation of ammonium chloride in the delivery tube. And then why excess of alkali is taken? So these are things that you must learn. Why is ammonia not collected over water? So these questions should be answered. You may understand preparation of ammonia. I have done a video on that. You can check the playlist under the chapter ammonia. You will find that. Then ammonia reacts with these substances: hydrogen chloride, copper oxide, oxygen and chlorine. These reactions are also important. NH3, ammonia reacts with HCl. What you get is NH4Cl, dense white fumes. Dense white fumes of ammonium chloride is formed. Ammonia acts as a reducing agent when reacted with copper oxide when heated. So you have copper plus water plus nitrogen. Okay, so 3Cu, 3CO, 2NH3. So 3 oxygens will be there. So 3 H2O, 3 copper and N2. Okay. Then ammonia reacts with the other substances mentioned here, oxygen and chlorine. Oxygen is NH3, ammonia reacting with oxygen in the presence of platinum catalyst 700 to 800 degrees Celsius. Here you have NO plus H2O, nitric oxide and water, 4, 5, 4, 6. Don't forget this reaction is an important reaction. It will come. Then ammonia burning in oxygen, NH3 plus O2 will give N2 plus H2O. So it will be 4, 5, 4, 3, 2 and 6. Okay, this is another one, greenish flame. It will give a green flame. Okay, pale green flame. And then we have ammonia reacting with chlorine, NH3 plus Cl2. There are two reactions. When chlorine is in excess, it will form nitrogen trichloride, NCl3 plus HCl, 3Cl2, NCl3 and 3HCl. Okay, and ammonia reacting with chlorine. Here ammonia is in excess. Here what you will have? You have NH4Cl plus N2. So this will be 6 and 8 and 3. Okay. Then Haber's process. Haber's process is manufacture of ammonia N2 plus 3H2. Reversible reaction. What is the catalyst? Finely divided iron and molybdenum. 450 to 500 degrees Celsius. 200 to 900 atmospheres pressure. The product is NH3, 2NH3. N2 plus 3H2 gives 2NH3 and it is exothermic reaction. Preparation of nitric acid in the laboratory. Another important topic is how do you prepare nitric acid? You take NaNO3 and H2SO4 concentrated sulfuric acid. Temperature below 200 degrees Celsius. You have NaHSO4 plus HNO3. All glass apparatus use the temperature above is 200 is also possible, which is not preferred. Instead of NaNO3, you may also use KNO3. Why all glass apparatus? Because the vapors of nitric acid are highly corrosive. They attack and damage rubber, cork or wood or any laboratory material other than glass. Then Ostwald's process is manufacture of nitric acid. What are the reactions in the Ostwald's process? The first will be in the Ostwald's process ammonia. Ammonia is oxidized, catalytical oxidation of ammonia, PT and 800 degrees Celsius. NO plus H2O, 4, 5, 4, 6. Don't forget this reaction, it will come. And NO plus O2 will give NO2, the next reaction. Okay, 2NO plus O2 gives 2NO2. The next reaction will be NO2 plus O2 plus H2O will give HNO3, 4 and 4 and 2. Okay, remember these reactions of Ostwald's process. Contact process. Here we have sulfur dioxide being produced. Sulfur burns SO2 or FeS2 iron pyrite plus O2 will give Fe2O3 plus SO2. 3, this will be doubled, 4. So 4 FeS2, 4 2 is 8 sulfur, so 8 SO2, 8 2s are 16, 2 3s are 6, 22, 11 O2. Okay, SO2 is produced. Now SO2 plus O2 in the contact tower, vanadium pentoxide catalyst, 450 to 500 degrees Celsius, 1 to 2 atmospheres pressure. Here you have SO3, 2 SO3, 2 SO2, and then SO3 will react with the corn sulfuric acid, that is 98% sulfuric acid, to give H2S2O7 oleum, and then oleum H2S2O7 diluted with water will give 2 molecules of H2SO for reactions of contact process. Please remember this. Then Gay-Lussac's law. What are the definitions? Gay-Lussac's law. Whenever gases react, they do so in volumes that bear a simple whole number ratio with one another, and also with that of the products if gaseous, provided all volumes are measured at the same temperature and pressure. Okay, so this is Gay-Lussac's law. Remember this. Now there can be problems on the basis of Gay-Lussac's law. Example, if they ask you a reaction like NH3 plus Cl2 gives NH4Cl plus N2. Okay, 6, 8 and 3. Okay, now if you know this is 8 volumes, this is 3 volumes, this is 6 volumes, and this is 1 volume. If you know the volume of one of this, the others can be calculated. If 8 volumes is known as what you can take it as 22.4 liters, then what will be this? This will be upon x. Equate this, cross multiply, you will get this. This can be y and this can be z. So you can equate them. 8 upon 22.4 is equal to 3 upon x, that is equal to 6 upon y, that is equal to 1 upon z. So cross multiplying, any answer can be taken out. Then mole in terms of volume, number of particles and mass. Mole is, what is mole? Number of moles is equal to volume of gas at STP divided by 22.4. Secondly, number of moles is equal to number of molecules divided by 6.023 into 10 to the power 23, Avogadro's number. And thirdly, number of moles is equal to mass in grams of substance divided by molecular mass. Okay, so these are the formulae for calculating number of moles. This can also be asked, anything can be asked to convert. Example, they can ask you to convert you have how many moles? Okay, example, you have 9 grams of water. 9 grams of, how many moles are there? Number of moles equal to mass in grams divided by molecular mass. Water, hydrogen is equal to 1, oxygen is 16. So 2 hydrogens make 2 and 16. So 18 is the molecular mass. So here it will be 9 upon 18 is equal to 0.5 moles. Okay, so any question can be asked. Similarly, volume can be given and question can be asked. Number of molecules can be given and questions can be asked. Now vapor density, empirical formula and molecular formula. Vapor density is equal to molecular mass upon 2. Okay, if vapor density is 24, then what will be the molecular mass? Molecular mass will be 2 can be brought here into 2, so equal to 48. So 48 will be the molecular mass. Then empirical formula and molecular formula. Empirical formula multiplied by n is equal to molecular formula. Example, if you take benzene. So benzene, what can be there? C6H6 is the molecular formula. CH is the empirical formula. N is equal to 6, so multiplied by 6 you will get molecular formula. So this can be there. Then calculation based on data can also be there. They can give you some data and ask you to calculate the number of molecular formula and empirical formula. If they can give you percentage composition and those questions, I have done it all under this chapter gas laws in detail. You may go and see that video. So these are important questions. Then ores of aluminium. What are the ores of aluminium? The chief ore is bauxite, having the formula Al2O3. Aluminium oxide is there. Okay, and then cryolite is Na3AlF6, and fluorspar CaF2 is another one. No, it is used in Hall-Herold's process. These are the O's. One more is corundum. It is Al2O3. Okay, now this may have hydration in it. Bayes process. What is the purpose of Bayes process? Bayes process is concentration of aluminium. What is done here? NaOH is reacted with the bauxite Al2O3 dot 2H2O. Okay, so you will get NaAlO2 plus H2O. Okay, so NaAlO2, 2 NaOH, 2 NaAlO2 plus 3H2O. Okay, and then NaAlO2 plus water is added to it. So here you will get NaOH plus AlOH whole thrice. Okay, so you will have 3H2O here, 2H2O, 4. Okay, and then AlOH whole thrice on heating will give Al2O3 plus H2O. This is aluminium hydroxide. Okay, aluminium hydroxide is a white precipitate which will be ignited, will give Al2O3, 2 AlOH whole thrice and 3 H2O. Okay, then Hall-Herold's process is extraction of aluminium from bauxite. So Al2O3 dissociates as Al triple plus, 2 Al triple plus 3 O minus minus. Then we have the complete detail, the anode and cathode, and then reaction at anode and reaction at cathode. At anode, the oxide ions will give nascent oxygen plus 2 electrons, which will be multiplied later. Then Al triple plus will give plus 3 electrons will give Al. Okay, now this will be multiplied by 2 and this by 3, because 3 electrons and 2 electrons, 6 electrons. So this will form 3 O minus minus, giving 3 oxygens plus 6 electrons, and here 2 Al triple plus 6 electrons will give 2 Al. Okay, so these reactions are important, anode and cathode. Then there are alloys. What are alloys? Alloys are homogeneous mixtures of 2 or more metals in a certain proportion. Okay, we have solder. Solder is lead and tin. Okay, so here it is used for, it has low melting point, so it is used for as electrical fuse. It is also known as fuse metal, electric fuse, and for soldering of electronic circuits, soldering purposes. Stainless steel, used for making cutlery. Cutlery is a set of forks, spoons and knives, shaving blades, wristwatches and so on. Then brass is copper and zinc, so it is used for making nameplates and also decorative articles. And then bronze is used for making medals and statues. So copper and zinc along with other metals like tin and lead can be along with that in bronze. So these alloys you must study. Then what is amalgam? Amalgam is a alloy. It is an alloy in which mercury is one of the constituents. The details are there in the topic in the chapter metals. I have discussed with that in details there. You may go and see that. So that is all in this video. So please study these topics. These are important for your exams. Thank you.